No. So this is, in our textbook, this is section 5.6, and it's integration by parts. And so we're looking for, so everything else on my list has failed. This is the next process I'm going through, right? So, and it's kind of nice in that it'll be pretty obvious that I need to do by parts. So I'm looking for a function u and a derivative of a function v, right? Yes, you see me? You see the u and you see the dv. U is the function, dv is a derivative of v, right? And I get uv minus the integral of v du. So secretly, this is hidden as a product rule. Okay? This is a product rule. If you think about, if I had two functions uv, and I did the derivative of that product, right? I would have the first function times the derivative of the second, plus the derivative of the first times the second. And so, right, you agree with me there? You remember, like my class, we did it as a loop. We did a u and a u prime and a v and a v prime. So you can see my u dv, right, and v du. And then, of course, I mean, this is a pretty easy proof here, right? Because what am I going to do to both sides? I'm just going to integrate, right? What happens on the left? What happens on the left side of my equation? Yeah, antiderivative of a derivative. What happens? I just get uv. They cancel, right? Fundamental theorem of calculus. If you integrate a derivative, they undo each other, right? And look what I get on the other side. I get the integral of u dv plus the integral of v du. Do you see it already? Right? One more step, right? Just subtract the integral of v du, and I've got exactly the formula that they're saying is true. Now here's the thing. I have to pick the part for u and to pick the part for dv, okay? So we're going to pick u via Liate. Logs, inverse trigs, algebraic, what's t? Trig, yep. And what's e? So you're going to start off by picking u. Is it okay if you make a mistake? Of course. How are you going to know if you made a mistake? If you can't integrate, if you pick it and you can't do anything with it, right? Or the real thing is, it's going to get worse. It's going to start to look worse, right? You're going to start doing the problem. It's going to get worse. It's going to get more complicated, right? Then you're probably going the wrong way. The book is saying your VDU should not be more complicated than your UDV. Okay? So meaning if your you pick a sine of x, and your dv becomes sine squared of x, that's more complicated. You don't want that. The most complicated thing should be the pick of u. And then dv, your second choice, what's left over, should be simpler. Okay? I don't think that note is needed, but it's what's in our book here, right? It's also saying the part you pick as dv, you better be able to integrate it. So, but that kind of leans toward it shouldn't be more complicated, okay? Now, when we do this process, we have several levels again. Level 1 is easy. U will be obvious, everything will be obvious. Level 2 could be a loop that I have to do by parts within a by parts problem. And level 3 is a shortcut called tic-tac-toe. So we want to talk about just some simple examples. We want to talk about loops, and we want to talk about tic-tac-toe. Tic-tac-toe is a shortcut version of it. That I want to make sure that you do a tic-tac-toe problem the full way with a loop and with a shortcut. I often ask you to do that on the test. Do this integration by parts problem with the shortcut and I'll call it the long cut. Something like that, something stupid like that. All right, let's do my favorite problem of all time to do here, and that is the integral of ln of x dx. And what do students instantly say the answer is? As a mistake, what answer do they say? 1 over x, but that we're doing the antiderivative, not the derivative, right? Well, I don't have much choice for my Liate. I do see algebra there. There's a factor of 1, and there's a factor of ln, right? Ln, the function ln of x. But ln is first on my list of Liate, right? So I'm going to let u equal ln of x. Everything else is, so I've got my u, I need my dv. Everything else is dv. So dv has got to be what? What's left in terms of dx? That's it. Once you pick your value of u, everything left is dv. Right? Now, remember what I want. Right? What's my formula? The antiderivative of ln of x dx is uv. Right? I need a u, I need a v, I need a minus the integral of don't tell me. V du, right? Yeah. All right, I have a u. I don't have a v. What do I do to get the v? What do I do with this to get a v? I integrate. The integral of dv should be the integral of dx, which means v is x. Right?
Yeah.
All right, look at what I need in my formula. I need a u, got it. I need a v, got it. I need a v, got it. I need a du. I don't have it yet. How do I get du? I just differentiate. So I pick my u, do the derivative of it to get my du. I find my dv, I take the antiderivative of it to find my v. Four. Yeah. If you look at the formula, right? uv minus the integral of v du. So u and v and du, right? Some of them are easily found, some are not. But I'm trying to organize myself this way. So I've got my u, that's ln of x. I've got my v, that's x. I like to rearrange them as I'm writing them to have them make sense. Minus the integral of v du, right? So that's x times 1 over x dx. Huh. Simple. What is that? The integral of dx, what is that? Just x. Right? The integral, what did I take a derivative to get 1? Right? There's a 1 here, right? There it is. The integral of ln of x dx is x ln of x minus x. How do I double check? Differentiate. Take the derivative. Make sure I get back to the original. I'm doing the product rule in my head here, just so you know. Right? Because you're all grown up. You're past Calc 1. I'm doing the product rule in my head. First function times the derivative of the second function plus the derivative of the first function times the second function. I'm still, to me, if you had me for Calc 1, I'm still doing that loop. But I've done it so many times. Right? Look at that loop. Don't write in green. F prime, G prime. First function times the derivative of the second plus derivative of the first times the second. So I'm doing that product rule pretty quickly. But whatever you need, just make sure you're practicing. All right, another? Yeah? So it's kind of interesting to try by parts even when an earlier process works. It's kind of interesting to do that. Like I just had a function ln of x. None of my processes would work for that. But if I just had a function sine of x, I already know how to do the antiderivative. But guess what? My parts works. It's a lot more work than just do the antiderivative of sine, but it's kind of nice that if you miss one of the processes, another one could still work. Another one could pick it up. Let's do the integral of x e to the x. So if I go through my process, all right, is there a u sub I could do? You'll see right away, everything fails. Everything on my list fails, right? I mean, what could u be? It could be a whole function. No, that doesn't work. Could be the inside. The inside's too simple. That doesn't work. There's no downstairs. It's definitely not an arc inverse trig, right? It fails pretty quickly on my list. So next thing is by parts. And look at my Lyautey list. So what's going to be my first choice? Remember, we're going L first, right? So trig exponentials are last. So is there something on my list before that? Yes, there's some algebra, an x. So I got u. I want to find du. Done. 1 dx, right? I've got dv. I want to find v, and that is the integral of e to the x dx, which is just e to the x. We don't care about the plus c version here, right? And I guess I should have put plus c at the end of my last problem, right? When I did the integral of ln of x, it should have been x ln of x minus x plus c. But when I'm doing this process, I don't bother with the plus c until the end, right? Everybody okay here? It's a pretty easy list. That's something I'd have on my formula sheet in case I forgot. Lyautey, right? Say again? Everything else. So I decided that x was my u. Everything else is dv. Then I integrated. So yeah, integrated, right? So the integral of dv is just v. It's weird at first, but you'll get used to it real quick. These aren't difficult. The trig substitutions are difficult. All right, we're ready. The integral of x e to the x dx. I need a uv. Oh, that's x e to the x. Minus the integral of v du. Pretty simple if you're organized. Oh, and that last integral is nice, isn't it? So this is x e to the x minus e to the x all plus c. This one is a shortcut candidate. If I find u, and I get u prime, and then u double prime, and u triple prime, and u quadruple prime, and eventually I go to 0, then I'm okay with the shortcut here. So u is x, derivative is 1, derivative of that is 0. So this is a shortcut possibility. Our first problem was ln, right? U was ln, right? Derivative is 1 over x. Derivative of that, minus 1 over x squared. Derivative of that, minus 2 over x cubed, derivative of, it's not going to go to 0. Right? I need the u, if I keep taking a derivative of it, I need it to disappear eventually. And if that works, the shortcut works. Here's my shortcut. You ready? And I'm calling it tic-tac-toe. Yes. The shortcut I call tic-tac-toe. I want to do my sine, my u, my dv. I'm always going to start positive and alternate. I start right away with my u, which was x, and I differentiate. So x, and then 1, and then 0. My dv, right? I'm going to not start with dv. I want to start with v. So I have to integrate. So I have to start with v. What did I get for v? E to the x, integrate again. E to the x, integrate again. E to the x. Tick, tack, toe. You see it? My first term is positive x times e to the x, yes. My second term, I'm reading the line across, negative 1 e to the x. The last term, positive 0 times e to the x. Once I get to that 0 line, I'm done, right? Don't even need it, really, right? But notice, look at my answer. Positive x e to the x, right? Minus e to the x. Tic-tac-toe. Let's look at a loop. Okay, we're going to do a loop, then we'll do the loop. The loop one I'm going to give you actually will allow me to do the shortcut. Okay, so we see them all together. We ready? Oh no, the loop, will this loop allow me to do? Yeah, I think so. I want to do the integral of x squared e to the x. Now what's going to start to happen, of course, is it's going to start to get more complicated, because that's what we do, right? Us math people, we give you a problem and then we make it more complicated. So it's going to start to have chain rule involved and that kind of thing. But let me just do this one first. Is this a shortcut? Does this have shortcut potential to it? Yeah, so my Liate list, right? What's going to be choice for u? X squared, right? Yeah. And does that derivative eventually go to 0? Yes. So this is a shortcut. This is one I can do with the shortcut. But I'm going to do it by parts first. So I got u is x squared. So that means du is 2x dx. dv is e to the x dx, same as before, and v is e to the x. Is that okay with everyone? This is easy, right? You're like, this is easy. Why didn't they teach me in Calc 1? Because we don't have time. We don't have time. We got to stop somewhere. So, so the integral of x squared e to the x dx is x squared e to the x, right? uv minus the integral of v du. So you can see why I'm talking about a loop. Loop's not fair, I guess. I would say it's by parts and by parts again, right? So, yeah, so minus the integral of v du. So minus, right, v du. Oh. Yep. Well, can I cheat? Didn't I do this one already? Didn't I do x e to the x already? Yeah, so I got x squared e to the x minus 2 times x e to the x. I forget. Yeah, minus e to the x. So sometimes when you do by parts, you'll have a by parts inside of it. So I still didn't talk about the loop. I'll talk about the loop in a second. So we really have 4 things. Just using by parts, having by parts inside of a by parts problem, the loop, which I haven't talked about, and then the shortcut. Now, this one's shortcut potential, right? So let's do this one with shortcut. So sine u dv. Plus, minus, plus, minus, plus, minus, right? Alternate the signs, always starting with the positive. U is x squared, then 2x, then 2, then 0. Double check me there, please. dv was e to the x dx, right? But we want v. We want to integrate, 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 integrate. So, and that's just e to the x every time. Obviously, we don't need this last line, right? Because 0 times anything is gone. And you can see the factor of e to the x there. And you can see my polynomial, x squared minus 2x plus 2. Yeah, you with me? Yeah. So multiply plus multiply plus multiply. Right? So I got x squared e to the x minus 2x e to the x plus 2 e to the x plus c, right? But I can see that I can kind of make this first piece look a little bit better. By factoring. The thing about missing a class is, one, it's no good. But if you have to miss, you have to miss, right? But I'm expecting you, after this class, to be able to do by parts anytime it comes up. Right? And that's the thing. You have to practice. In the summer, you have to practice at night, because the next class, I'm expecting you to be able to do the problem. Right? I'm not going to teach by parts on Wednesday. You're supposed to own it already. That's what makes the summer class tough. So, and then if you miss a class, and we're doing by parts next class, you're going to be like, what the hell's going on? Right? So, I mean, at times you have to miss class. I understand that. If you get sick, what can you do? Right? You get in a car accident, you can't, right? So we're not in control. It's just you have to accept. If you get sick and you can't keep on the class, you're probably going to have to do it over, and that's fine. You just make sure that you talk to me in all situations, because it might be a way for you to get your money back if you were sick, or to have it. I don't know. Does financial aid work in the summer? I was on financial aid, but I don't remember. I think I kind of had to pay out of pocket in the summer, but what's that? So if something happens, you want that money for sure, right? So just make sure you communicate with me. Let's do a loop, okay? And there's only so many problems, right? There's only so many problems. And this thing I gave you, the Shams, it's like every problem you could ever be asked to do. So, like, just looking at the problems, number 1, x sine x, right? Number 2, x e to the x. Number 3, x squared ln of x, right? You can already see that we're not doing much here. It's number 4 is kind of nice, because that is, if I did substitution inside, I'd have leftover x's. So that one's interesting. So there's one that could be done both ways. So, but certainly you should do these. Once I get up to secant cube, it's pretty nasty, that one. Number 10 is a good shortcut. 9 is a good shortcut. All right, let's do this. The integral of e to the x sine x dx. This one I'm claiming is a loop, and what we're going to see it's my terminology, okay? When we see the original function again in the problem, we know we're back to the beginning again. Okay, so that's what I'm calling a loop. What's my choice for u? Yeah, trig, right? Trig comes before exponential, so trig, sine x. What's the derivative of sine? And then dv is e to the x dx. Oh, that's nice, because v is e to the x. I like when I don't have to do too much. I'm going to do one with a nasty version of v in a second, okay? So, but we got our little process here. E to the x sine x dx, that integral is uv minus the integral of v du. Well, I got to do by parts again. That's not what I'm calling a loop, right? But when I do the by parts again, believe it or not, I'm going to get another integral that's going to be e to the x sine x dx. And that's my loop. That's going to get me back to the beginning. So watch how I do this process, right? I need to pick a u again. It's going to be cos of x. The du is negative sine x dx. My dv is still e to the x dx. and my v is e to the x. So look at what I'm doing. I've got my whole original problem and then a new by parts problem inside of that. You see what I did? I tried to leave everything alone, but then treat that like a brand new uv minus the integral of v du, right? So you see I've gotten back to the original problem, right? And this is what I'm calling a loop. When I get back to the original problem. Sorry. So what I'm going to do is take that term on the right and add it to the left side. So I'm going to get 2 times the integral of e to the x sine x dx. Make sure you agree with me there. Right? So I added this integral to both sides, right? So I have it twice now on the left side. So final answer, e to the x, integral of e to the x sine x dx is e to the x over 2 times sine x minus cos x, all plus c. And you might say, well, did you divide c by 2? Yes, but then I renamed it c. How you feeling? So, I think a nice one for you to try, I think a good one to, well, let's do 10 by shortcut. But a nice one for you to try is sine squared x. Try that for me before next class, by parts. And obviously, there could be some confusion on what to pick for u, but there's not many choices, right? I could pick u as sine. I could pick u as sine squared. Yeah, I think both work. The one that won't work is u is 1, and then sine squared x dx is dv. That won't work. But I think you can pick u as sine and u as sine squared, and both of those should work. So try them both. Let's do 10 by shortcut and then go home. So normally right around this time I'd be given a quiz, right? One question, right? Do it, leave, right? And if anyone has extended time, that will allow me to give extra time too. There wouldn't be another class coming in here until 12, and there isn't. So, all right, let's try 10 here on Shams with the shortcut. And then go home. That sounds good, doesn't it? Go have lunch. Yeah? We're happy about, don't, somehow I shut my file down. Doesn't matter. So I've got x cubed e to the 2x dx. It's pretty obvious, LIA, my algebra's got to take the value of u before the exponential does. Right, you're understanding that? Go down that list. That's my choice for u. So u is x cubed. Do I need du? No. I need dv. For the shortcut, I don't need, I'm going to do my derivatives anyway, right? For dv, I have e to the 2x dx. And we're going to integrate that, but I need a u sub to integrate it, right? So I'm going to get a factor of 1/2 out here and a factor of 2 inside. If I let u be 2x, then du is 2 dx, correct? So if you can't do that in your head, then don't, right? I'm doing it in my head. But it's 20 years of teaching and 10 years of, how many years of college? 7 years of college, including advanced calculus, etc. So, do we agree with this though? So our shortcut, we need a sine, we need a u, we need a dv. For sine, I'm starting positive, negative, positive, negative, positive, negative. For u, I'm starting with my u and I'm differentiating, right? So x cubed, is that right? 3x squared, 6x, 6, and 0. Double check me, please. Yeah, my original v is 1/2 e to the 2x, right? I integrated to get that, and I want to keep integrating, right? But I already know what the derivative of e to the antiderivative of e to the 2x is. It's another 1/2 e to the 2x. So I'm going to get 1/4 e to the 2x, 1/8 e to the 2x, 1/16 e to the 2x. And of course I don't need the last one because of the 0, right? So we're getting a 1/2 x cubed. I'm just trying to pick things in order, kind of. 1/2 x cubed e to the 2x minus 3/4 x squared e to the 2x plus 6/8 x e to the 2x minus 6/16 e to the 2x plus c. Right? You with me? Right? There's my first term. Right? As a product. If you had me for Calc 1, you know, I like things to be factored as much as they can. What is their answer? Their answer is my answer right now, right? Right, in number 10? Yeah. I mean, I kind of would like it factored or reduced at least, right? So we certainly can factor out an e to the 2x, right? And we got x cubed over 2 minus 3x squared over 4 plus 3x over